Hey guys, here we are on part 2 of our unit on solutions. This section is about concentrations of solutions. So we're going to talk about some calculations. We're going to describe what molarity is and do some calculations. Molarity is really important in chemistry. If you looked inside our chemical stock area, you would see most of the solutions that we made are expressed in molarity. See this big M over here in these little pictures? This is how chemists make solutions. We'll also talk about dilutions and about percents. So there are a few definitions that we'll have to talk about here. So I've mentioned molarity. It is a very important way for chemists to measure the concentrations of solutions. So what does concentration mean? It's simply a measure of how much solute is in a solution. So if you had some salt and some water, it's how much salt is in that water. A dilute solution is when there's a small amount of solute. A concentrated solution is when there's a large amount of solute. So here's a little picture here. Here's some plain water. If we added some copper sulfate, we just added a little bit amount, this would be a dilute solution. If we added a little bit more, this would be a concentrated solution. And if we added even more, then eventually the solution would be saturated. We learned about saturated last week. It's the point where a solution will not dissolve any more solute. So keep those things in mind. So here's the formula for molarity. It's simply the moles of solute per liters of solution. Pretty simple calculation. We'll put the 5 moles on top of sodium chloride is dissolved in 2 liters. 2 liters goes on the bottom. 5 divided by 2 becomes 2.5 big M. Molarity is big M. We often call it molar. We'll say we have a 2.5 molar solution, but molarity, molar, it really means the same thing. It's a pretty simple calculation. So here's a couple more simple molarity questions. Again, our formula is going to be big M equals moles of solute, liters of solution. So the question says we have 0.5 moles of some solute. So the 0.5 goes on top. This says 200 milliliters of water. Milliliters, but our calculation has to be in liters. So we have to convert 200 milliliters to liters. Let me just show you using dimensional analysis. If we have 200 milliliters, we know that there's 1,000 milliliters in 1 liter. This comes out to 0.2 liters. All right, so make sure if it's a molarity problem, if this says milliliters, you have to convert it. So we're going to put 0.2 down here, do this math, and this also comes out to 2.5 big M. All right, let's try this one. How many moles, this time we're looking for moles of solute to make 15 liters of a 12 M solution. So let's write our formula. Moles per liter. Let's plug in what we're given. So it says it's a 12 big M solution. So I want to put that over here. Equals how many moles? That's our X up there in 15 liters. Okay, now we just have to do a little bit of algebra and solve for X. So this is an equal sign again. So we're going to go crisscross math. Do it this way. So 12 times 15 equals X. This comes out to 180 moles. Question asked for moles. So there's our answer. So be aware that you may have to solve for any of these 3 variables, but you'd be given 2 of them, so it shouldn't be that hard. Here's a couple more basic examples. Again, I'm just going to write the formula here. Molarity equals moles per liter. This says we have a 3.5 molar solution. I'll write that there. If you have 6 moles, What is the volume? Volume is down here. Liters is volume. So again, it's crisscross math. So we're going to do this. So we're going to go 3.5x equals 6. We're going to divide both sides by 3.5. And we come up with 1.7 liters. This was asking us about volume. So there you go. So be aware, you may have to solve for volume too, so you just crisscross. Here's another one. How many moles of NaF are needed to make 3 liters of a 4M solution? So again, I find it helpful if we write our formula, plug in what is given to us. It says we have 3M, we have 3 liters, and it's asking for moles, which is up here. Crisscross. 4 times 3. And this becomes 12 moles. All right, this one's a little bit more complicated because we're dealing with grams. This is asking us about grams now. What do you remember about grams? Grams equals molar mass times moles, right? One of our favorite formulas of all time. So we're going to have to use this and this to solve this problem. Write them both down. If you ever see the word grams in here, you're going to need this formula. Write it down, and let's just kind of take it from there. What is given to us? We have 3 liters. Where do we see liters over here? Here it is. It's down here, 3 liters. We're also given the molarity, 4M, big M, okay? So we don't have moles here. We're going to solve for moles. 4 times 3 equals X. This is 12 moles. Okay. Now we can use this here. We're solving for grams. So grams equals, what's the molar mass of sodium chloride? Sodium is 23. Chlorine is 35. That's 58. So the molar mass of table salt is 58 times our moles, which we got down here. 58 times 12, 696 grams. This is typically how you would use molarity in real life situations in the lab, because you would have to weigh out 696 grams. You would end up dissolving it in 3 liters of water, and you would get your 4 molar solution. Let's try another one. What is the molarity of a solution if 25 grams of lithium fluoride are dissolved in 1.7 liters of water? So I see the word grams. You should be thinking, grams equals molar mass times moles. How many times have we said that this year? And it's a molarity question. So you're going to need this. Molarity equals moles per liter. Okay, so let's just start plugging in things that are given to us. Here's 25 grams. There we go over there. Let's go 25 grams equals the molar mass. We can easily get the molar mass. Lithium is 7. Fluorine is 19. 7 plus 19 is 26. So grams equals molar mass times moles. We don't have moles. All right, so it looks like we're going to have to solve for that. But let's see what we got down here. We're trying to calculate molarity. Moles. Oh, look, we're going to get moles from here. Liters. There's liters. 1.7. Let's calculate moles. Let's divide both of these by 26. 25 divided by 26. Let's make it 0.96. And we're going to plug that in here. All right, so this is another two-step problem because it had the word grams in it. Grams. Make sure if you see that, you need to use this formula also. So now all we have to do is divide 0.96 divided by 1.7, 0.56, let's say. That's our final answer. Let's move along to dilution problems. So dilution, so if you say you had some tea and it tastes a little bit too strong, you would add some more water to dilute it, right? I think we're all familiar with the concept of dilution, so we do the same thing in chemistry. So you just have to be aware that you still have the same amount of tea particles in your cup. You're just adding more water. So the same thing happens with chemistry. If you're diluting a solution, it reduces the number of moles per unit volume. You still have the same number of moles. It's the same number of tea particles. You're just diluting it by adding more of your solvent. So there's a calculation involved with this. Here it is. M1 V1 equals M2 V2. Big M is molarity. V is for volume. In this case, it could be liters or milliliters. It doesn't really matter. You just have to keep it the same on both sides. You can't have liters on one side and milliliters on the other. They both have to be either or. So let's look at an example of how we do these calculations. I'll write the formula here. M1 V1 equals M2 V2. How many milliliters of a 2 molar sodium chloride? So the trick to these is keeping these together. We've done these kind of problems before. So it's asking for how many milliliters, so that's volume, that's over here, of a 2M solution. So we're going to put the 2 here. The 2M is associated with some unknown volume. How many milliliters of 2M must be diluted with water to prepare 100 milliliters? There's our second volume of a 0.4 big M solution. So again, this 100 is going to go with the 0.4, as I did over on this side, and the how many, the X, or volume here, is going to go with the 2, which I did here. Now all we have to do is solve for our unknown. So let's just clean this up a little bit. This will become 40. 2V equals 40, divided by 2. V equals 20. Let's try another one. Oh, good. During a lab, you need to make 2 liters of a 3M solution. All right. So let's get our formula. M1 V1 equals M2 V2. So we need to make 2 liters of a 3M. So our volume is 2. All right, this is volume. Liters is volume. 3M, this is our molarity. So I'm just going to put it there. I'm leaving the units out just for clarity. It's always a good idea to put your units in. How many liters of a 12? So the how many, the X, the volume is going to go with the 12. So I got the 12 here. Pretty much the same question as before, different numbers. Here's our unknown volume. Okay, let's solve for X, or V in this case. Divide by 12 on both sides. Remember, you always divide by the side of where your unknown is. Notice how our units of volume are in liters this time on both sides. Liters, liters. So our answer is going to be in liters. So there you go. So here's our beaker. Kind of a rectangular looking beaker. So what you would do is you would take half a liter of this. So you would take 0.5 liters of your 12M solution. So this is your 12M solution. It says you need to make 2 liters total. So this total volume is going to be 2 liters. So you're going to take the 0.5 liters, that's half a liter, of your 12M solution. You're going to put it inside your beaker here. You need a total volume of 2 liters. So how much water are you going to put in? How about 1.5? Because 1.5 plus 0.5 is going to give you your total volume of 2 liters. So you're going to end up with 2 liters of a 3M solution. So you diluted. You had a 12 molar solution and you ended up diluting it to 3 molars by adding this much of your 12M and 1.5 liters of just plain old water. All right, and finally, let's just talk about percent solutions. It's just another way that concentrations are expressed. Right now, if you go into your medicine cabinet, you may have some rubbing alcohol. It probably says 70% alcohol on it. So that's a 70% solution. That's a measure of concentration. So a lot of times concentrations are either expressed with volume or by mass. It really doesn't matter. The calculations are the same. But just realize that volume deals with liters and milliliters, and mass does it by grams. So you could weigh out liquids just as easily as you could measure their volume in a graduated cylinder or whatever. A lot of times if you look on packaging, it'll say volume, percent by volume, or it'll say percent by mass. It really doesn't matter. It's just different ways to do it. All right, so here's a couple quick calculations on how to do this. If there are 35 milliliters of ethanol and 250 milliliters of solution, what is the percent? So our formula is percent equals the volume of your solute divided by the volume of your solution. So times 100. Okay, so it's our 35 milliliters. Remember, the solute is always the one that's in the least amount, so you're going to put that on top. It says our solution is 250. Simply do this math, and that comes out to 14%. Okay, pretty easy. Okay, let's try another one here. Bottle of hydrogen peroxide is labeled at 3%. So this time your percent is given. So I'm going to put that over here. 3% equals how many milliliters of hydrogen peroxide, which is your solute, are in 500 milliliters of this solution. So remember, percents are always part over the whole. We've did that before, right? So here's the peroxide, here's the water. So if you did this math, you're going to come up with 1,500 milliliters. But be careful here, because when we calculate percents, when we do it this way, we're multiplying by the 100. So if you're going the other way, you're going to have to divide by 100. This gives us 15 milliliters. And this makes more sense. If you have a 3% solution of 500, how can your answer be 1,500? It can't be, because that's more than what you even started with. So because of this 100 here, you have to divide it by 100, and this is your answer. And this makes sense. You could check it. You could take your 15 divided by your 500 here times 100, and you're going to get 3%. Okay, if you wanted to, instead of putting 3% here, you could divide the 3 by 100 over here and do it in decimal, equals x over 500, and then you're going to get 15 milliliters. Either way, but just remember, because of this 100 here that we're dealing with, be careful when you're doing this calculation. This is really your main formula that you're dealing with.